And then particularly the machine learning performance, I actually provide several measurement of the performance. Yeah, in the machine learning, there are many measurement is very common, like confusion metrics and an accuracy, confusion metrics for the accuracies, and then the speed of the calculation or speed of the training based on the certain data set. But I'm kind of provide additional measurement factors. So actually this measurement factor, you can use it on your machine learning system during the training or during the evaluation. You can use them. This one actually coming from the quality engineering, which is another area. It's not like a computer science, but the more likely the industrial engineering or Six Sigma and so forth. So I'm kind of bring up the sum of these factors. And then these factors actually introduced it for my previous research also. So you can take a look at in details how it works. And then I'm strongly recommend if for instance, you developing the certain machine learning system, either it's authentication or the classification, regulation, whichever you called it, you can use this measurement, how good it is, how your system is good, how the performance is good. You can give that an idea to or persuade to your reviewer based on this kind of a measurement. So I'll skip it for details regarding this measurement, because that is not the part. I mean, the explanation about this measurement is not the part of the research in here. And then the other idea which I'm still looking for is that so-called mode-based standardization. I believe that if you are in the statistics, you know about how to get the so-called normalization, right? So it's a typical SSG, and then you know that how your variances change, and then your normalization based on the mean, and then this is a condition. Once the number of samples is bigger than the sample means becomes the means of the mother set, and then the standard deviation is also follow the samples of standard deviation will be follow the standard deviation of the mother set, right? That is very commonly used in the statistics to get the measures and so forth. But frankly speaking, I believe the mode is which is the highest probability to get an action. That will be the more proper, especially if you design the engineering system, because sometimes mean doesn't give nothing. For example, like if you flipping the coin, for instance, if you flipping the coin, the average of the flipping the coin is half, right? It's like the 0.5. But in the real world, it's not. There is no 0.5 in the coin. There is either you toss the head, which is 1, you toss the tail, it's 0. So either 1 or 0. There is no 0.5 in the real world, actual event. So similarly, if you're dealing with the machine learning system, you'd better take a look at what will be the highest probability, which is basically mode, and then you kind of decompose it or compose it to some sort of normalization based on the mode, not based on the average. I mean, as you know, most of probability distribution, almost the mean is the same as a mode. I mean, that's like a Gaussian or the exponential. Most of well-known probability distribution, the mean is the same as a mode, but not the general distribution or not the distribution coming from the practical measurement, practical data set. It's not always true. So that's why I give you some idea to how to normalize them. So how to get the W, which is equivalent with the Z, and then the sigma, which is equivalent with the sigma in here and so forth. So you can have some formulas for that. This one is kind of theory, but actually this is the first time I introduced in this paper. But next time, if I developing the machine learning system, I'd rather go with try to use this formula, which might give you the better performance of the system. So as a summary, compact data set is contained the maximized knowledge patterns in the fine ground level of effective and personalized utilization of a big data system without the big data. That's the whole point. So instead of handling the big data by itself, you rather going with the more compact data would be the better for your, not only for the system by itself, also for the performance wise would be the better. And then it's kind of a tailor-made design. So which actually is it looks simple, but actually it's not a simple because it depends on the what kind of data you're dealing with. So you should understand the nature of data first, and then you should understand the system first before you doing or you using the data by itself, or you make a tailor-made compactizing the data. Doing before that, you should well know about the data by itself. It's coming from the business or consumer, or is coming from the internet traffic, or is it coming from the biometric human data? Yeah, all of data set have a different characteristics, and then if you don't know the characteristics of data by itself, you cannot compactizing the data. That is a bottom line. So you should well know about your subject first before you compactizing the data. And then last be that compact data can be even more suitable, especially if you want to develop the engines in the IoT devices, like you making the machine learning authentication system on the smartwatch, for instance. So that kind of cases, you cannot have a big data to handle on the IoT devices or like a small performance devices. You cannot do that. So you should somehow compactizing the data before you put that data into the IoT devices.